As we begin our study of the Calculus BC material, it makes sense for us to begin with a review of differentiation, so taking the derivative. So I just want to remind you of things that you need to recall. The constant rule, which says that the derivative of a constant is 0. The constant multiple rule, which says that if you've got a constant multiplied times something, you can take the derivative of the something and just multiply by the constant later. The addition-subtraction rule just says that when you have two functions added, you can take the derivative of each one individually. Then there's the chain rule. The chain rule is one that I'm going to spend a little more time talking about later in this video. Hopefully you remember the chain rule. And then the big one, this is huge. There were a lot of derivatives that you memorized. Some of you memorized them, some of you not so much. We need to have those things memorized. We need to know those things forwards and backwards. They need to be very, very quick on our minds. So if you don't have those memorized, get those flashcards back out. Finally make some flashcards. Get yourself committed to know those and know them well. We also need to know the product rule and the quotient rule. We'll cover those a little bit later. This is all supposed to be a review, but it's good for us to sort of, review and remember it all. So I'm going to dive straight into an example. Find dy dx if y equals the secant of x squared. And I sort of used this example as a way of, I guess, reminding you of how to use the handout of derivatives and integrals that I gave you guys at some point last year. Right? On that paper, it tells you that the derivative of secant x is equal to secant x times tangent x. Got a little bit squunched there, but you get the idea, right? So in this one, if I want to take the derivative of the secant of x squared, notice that there's something plugged into that secant. I'm going to take this derivative by saying, okay, dy dx will be, follow this rule. This rule says it's supposed to be the secant of whatever was inside times the tangent of whatever was inside. So this will be secant of x squared times tangent of x squared. And then the chain rule tells us that we multiply by the derivative of that thing that was inside, which is 2x. If it was me, I would probably put that 2x in the front. I would get dy dx is 2x secant of x squared times the tangent of x squared. Right, so I sort of use this as a way of mentioning that handout of derivatives and integrals still totally applies, still super valuable. So use it, know it, memorize it. My next example, find y prime if y equals 5 tangent x minus 4x squared plus 17. A part of this is memorizing trig derivatives from before, and a part of it is remembering how addition and subtraction work for derivatives. So, if you're up to it, pause the video, find this derivative. Should be y prime is 5 times, because our constant multiple rule just says we can sort of ignore the 5 for a second. The derivative of tangent is secant squared x. We don't need to use the chain rule here because it was just an x that was inside. If this had been a 2x, we'd be multiplying by 2. But it's not, so we move on. Next up, we sort of have that power rule, right? Remember, you bring this 2 down. So 2 times the negative 4 gives me negative 8x, and then plus the derivative of 17 is 0, and so this is our basic derivative. Here's another example. Find g prime of x if g of x is sine squared of 5x. This is a problem that we did a number of times last year, so I hope you remember it. I'm going to ask you guys, pause the video, try this on your own, sort of see what your brain does with it. I really believe that until you get good at these, your first step anytime you see sine squared is to realize that means the sine of 5x squared. Right? And when you see that, you recognize this is a chain rule problem. In fact, this is a double chain rule problem. Right? The way it's going to work is I'm going to say, okay, this is something squared. And so when I take the derivative of something squared, g prime of x will be 2 times this thing, I leave the inside alone, raised to the first power, times the derivative of what was inside. But that derivative is the sine of 5x. It's a chain rule of its own. The derivative of sine 5x will be cosine of 5x times the derivative of what's inside of that, this 5x that we had left over. So multiplying that, we'll get another 5 on the front, rather at the end. And so again, I'm going to take a second to sort of pretty this up. I'll multiply the 2 and the 5 together to give me 10 sine 5x times cosine 5x. And this is my derivative. So now here's this last one, right? Find dy dx if y equals 1 over the arctan of x. We could use the quotient rule for this. You could do the low d high minus high d low, square the bottom, and away we go. But a lot of times when it's 1 over something, I find that it's a lot easier to think of these problems as just arctan x to the negative 1. So when we take the derivative, when we take dy dx, I'll bring the power down. This negative 1 will come up front. So negative 1 times arctan x, and I have to reduce the power by 1, so it goes to negative 2, times the derivative of what was inside. Now what's the derivative of arctan x? Ends up being 1 over 1 plus x squared. Right? And so this is not, the prettiest problem in the world, but, we can write it down. dy dx is negative 1 over 1 plus x squared times arctan x squared. Again, not pretty, but that is the derivative. Okay. So this was sort of intended to just kind of be a basic overview of some of the derivative rules, hopefully reminding you of some of them. The practice that you'll do in class tomorrow, or that you may start tonight, is going to involve all this stuff and more. So just get back into the swing of things.